Hello, in this video, let's talk about solving a polynomial inequality. So here is an example. It's a polynomial, and instead of equal sign, it now has greater or equal. Now to solve it, we follow three steps. The first is we change the inequality into the equal and solve. So let's do that step. That means we now have x cubed minus 3x to the 2 minus x plus 3 equal to 0. And to solve it, we can use a graphing method. We can use factoring. Let's use factoring. So from the first, since we have more than 3 terms, we use factor by grouping. And from the first 2 terms, we can factor out x to the 2, leaving us with x minus 3. From the second 2, we can take out negative 1, leaving us also with x minus 3. And since x minus 3 is the same in both parentheses, we can factor x minus 3 out, and we will get x squared minus 1 in the second set of parentheses. Now that means, since we have a product, we're multiplying these two parentheses and the answer is 0. That only happens if either x minus 3 is 0 or x squared minus 1 is 0. Well, if x minus 3 is 0, that means x is 3. And if x squared minus 1 is 0, that means x squared is 1. And to cancel the square, we square root, and that makes x equals plus minus 1. So we have 3 solutions: negative 1, positive 1, and 3. The second step is we use these points to make an interval. So here is the x-axis, and somewhere there is negative 1, then there is a positive 1, and then there is a positive 3. So the second step is, once we plotted our answers to the equal to 0, we now have to test each interval to see if it's true or false. If it is true, then we shade that interval, and if it's false, then we don't shade it. And so let's pick a point that is less than 1. Any point less than 1 will do. Let's try negative 2. So that means if we substitute negative 2 into our original inequality back here, will we get the answer that is bigger than 0 or less than 0? So here's the calculator, and let's try it. So typing in negative 2 each time I see x, negative 2 to the power 3, and then minus 3 x, instead of x we have negative 2 squared, minus, instead of x, negative 2, and plus 3. And that turned out to be negative 15. Is negative 15 bigger than 0? So here is our diagram. We ended up with negative 15. That is not greater or equal to 0. That's false, which means we don't shade this interval. Now the next interval, negative 1 to between negative 1 and 1, the easiest point to use is 0. If we plug in 0 into our original inequality, that becomes 0, minus 0, 0, and we're left with 3 greater or equal to 0. Well, 3 really is greater or equal to 0, so that is true. So we tried 0, and we have true, which means this interval is going to be part of our answer. Now between 1 and 3, we can try 2. So back to our calculator. We can use second enter and re-enter the original expression. The only thing that needs to change is the negatives has to go. So I go through each parenthesis and remove the minuses. And that makes negative 3. Well, negative 3, is negative 3 greater or equal to 0? No. no negative numbers are greater or equal to 0. So once again, that's false, and we don't shade that interval. That's not part of our answer. Anything more than 3, well, we can test 4. So if we type in 4, second enter, and change all the 2's to the 4, we will get 15. Well, 15 is bigger than 0. That is true. So the last interval is going to be part of the answer. And the last step is now we write the answer in the interval notation. So since we had in the original inequality, we had equal sign. Each time we have an equal sign, we use bracket. And when we don't have an equal sign or we have infinity, we use parentheses. So we did have an equal sign, so we have brackets. Bracket, bracket, bracket. So our answer is bracket -1 to 1, and then union bracket 3, and goes on to infinity with the parentheses. And that's the final answer to solving our polynomial inequality. So here is the final result to solving our original equation, and that's the 3 steps. Make it equal to 0. Once we have it equal to 0, we put those points on the coordinate axis, and that makes intervals. Then we test each interval if it's true or false. Now we can also use the calculator to visually see this, because we can make an equation, we can sketch the picture of it, and we are looking for all the places where this expression is above the x-axis. So if we go here and we type in x to the power 3 minus 3x 3 minus 3x to the 2 minus x plus 3. So here is the picture. We're looking for all the places where this curve is above the x-axis, which is here between -1 and 1, and after 3 it's also above. So this picture visually is similar to our diagram. So this diagram is basically this graph showing that if we have any point that is greater than 3, then the graph is going to be above x-axis, which would be true for our statement. And if we pick any point between 1 and 3, then the graph is below, and that would be false for our statement, so we don't include it in the answer, and so on. So that's how this visual picture relates to this diagram and relates to this solution. And that's it for this video. That's how we solve a polynomial inequality. Thanks for your time. Take care.